Welcome to The Explainer. Let's just jump right into a pretty massive, kind of existential premise today. I want you to imagine, just for a second, a truly utopian world where machines do absolutely everything for you. Everything mundane, every chore, every complex calculation completely handled. It sounds like magic, right? But it also instantly raises a terrifying question that we're going to unpack today. If the machines do everything, what exactly happens to us? Do we still matter?
Can machines really think? And if they end up doing literally everything, what exactly is our purpose? What's fascinating is that this anxiety isn't actually new at all. Scientists and philosophers have been debating this idea of thinking machines for decades, going all the way back to the dawn of computing. So today, our explainer is going to take you on a journey to figure out if our human ability to make mistakes, that old saying, to err is human, is literally the only unique trait we have left, or if there's actually something much deeper that separates us from the code.
Section 1. Defining intelligence, the biological benchmark. Okay, let's dive right into this. Before we can even figure out if a machine is intelligent, we really need to define what basic intelligence actually is. Now, human consciousness, that is still a massive gap in our knowledge. We still don't entirely understand how the human brain functions. But structurally speaking, from a purely operational standpoint, intelligence is simply taking in sensory inputs, saying things, speaking, acting with our hands, just to coordinate and get stuff done in the world. And to really understand this, we don't just look at humans. We look at other, frankly brilliant, biological systems.
Take the Kinesis project, for example. We've known for decades that dogs can sniff out diseases. It's almost like elite dogs can actually smell time, because smells leave a trace of what happened in the past. In this specific project, a pack of elite dogs sniffs breath masks to detect volatile organic compounds, or VOCs, that are related to cancer. But the researchers don't just sit back and watch the dog wag its tail. No, they track brain waves, heart rate, respiration, body language. They create this massive multimodal time series database of biometrics. And then, an AI layer actually computes all of that raw biological data.
And here is the absolutely crucial takeaway from that. Even the absolute best, world-class human medical experts can be inconsistent. We're human. We have good days and bad days. But by combining those incredibly sensitive biological canine inputs with an AI computational layer, human volatility is entirely eliminated. The result? Dramatically improved early cancer detection and treatment outcomes. It's basically a perfect marriage of biological sensing and artificial processing.
Section 2. The evolution of computers, from math to mind. Let's shift gears a bit.
To really understand that AI layer we just talked about, we need to transition from biology over to machinery. The whole path to AI was basically born out of a need for sheer calculation. Back in the 1940s during World War II, if you needed to calculate a bomb trajectory, scientists would set up the equation, but actual people, mostly women working from their homes, did the multiplying and dividing. They were literally called computers. To automate that tedious math, the first physical computing machines were built. Fast forward a bit to the 2010s, and the internet just absolutely explodes, giving us a humongous amount of data. And by the 2020s, companies like NVIDIA effectively become monopolies by building modern GPUs, graphical processing units, that are capable of crunching trillions of bytes of that internet data boom.
But it wasn't just the hardware getting better. The entire approach shifted. Early computing basically treated pictures as just a matrix of numbers. Engineers tried to be really clever. They thought, okay, to teach a computer what an apple is, I'll write a complex algorithm to find exactly where the red pixels turn to black pixels to find the edge, and then deduce the shape. It was incredibly tedious. The major breakthrough happened when someone decided to stop being clever. They just gave the machines humongous amounts of data, like millions of handwritten 6s and 9s, and simply let the machine learn the patterns all by itself.
Section 3. The AI explosion, unlocking the black box.
The massive conceptual leap brings us right to today. AI can seem incredibly intimidating, for sure, but we can actually unlock the black box by breaking down how large language models actually function into 3 pretty simple steps. Step 1. The model ingests trillions of bytes of internet data. We are talking about the sum total of basically everything available on the web, a scale that is entirely beyond human comprehension. Step 2. It performs what's called autoregressive next token prediction. And step 3, it generates an output based on the patterns it learned.
Now, you might be wondering, what on earth is autoregressive next token prediction? It sounds like crazy complex jargon, but it is actually super simple in practice. Take the phrase, "the sun rises in the blank." The machine simply figures out,
based on those trillions of examples it ingested, that the most likely pattern to fill that blank is the word east. Modern AI is essentially just an impossibly fast, massively scaled game of fill-in-the-blanks.
Now, this leads to a massive, raging debate in the tech world. On one hand, we have narrow AI. These are systems that can converse, reason, and act as incredible tools. The Nobel Prize-winning AlphaFold, which explores the entire universe of proteins, is a perfect example of this. But opposed to that is general intelligence, the idea of a machine with actual sentience and core values. Tech pioneers are completely divided here. Skeptics, like the AI pioneer Yann LeCun, argue that simply scaling up these language models will never actually get us to true general intelligence. Others think we're right on the brink of it. And making this debate even more intense is the fact that because these models learned all on their own, we don't always know how to turn off certain AI behaviors. It genuinely is a black box.
Section 4. Surviving the New Order. The Adaptability Metric.
Obviously, this rapid advancement is creating a ton of socioeconomic anxiety. People are worried about layoffs, about 2 years of human work being replaced in a week. But consider the dinosaurs. They were mighty, powerful creatures with incredible strength, but they couldn't adapt to climate changes, so they went extinct. Humans, on the other hand, have survived because we are extremely good at adapting. When electricity arrived, it replaced bullocks on farms. It completely changed the map of the world. Historically, there are always groups, like the Luddites, who get upset and literally try to physically destroy the new machines. But our true historical strength as a species isn't fighting the tide. It's our phenomenal ability to adapt to new world orders.
It perfectly echoes what Charles Darwin famously said. It is not the smartest that survive, it is not the strongest that survive, it is the fittest that survive. And what you should really take away from this in our modern context is that being the fittest today means being the most adaptable to an AI-driven world.
And hey, if you're sitting there worried that AI will eventually solve absolutely everything and leave us with nothing to do, don't be. Remember the concept of entropy. The laws of thermodynamics dictate that the universe is experiencing a continuous increase of chaos. What that means practically is that the universe will constantly pose new problems. Human history proves that no matter what crazy new technology arrives, new challenges will always emerge. And whoever steps up to create new value in society by solving those new problems, well, they will always be rewarded.
Section 5. The Human Advantage, Beyond the Facade of Intelligence. Let's bring this all together.
If computers are going to handle the math and the coding and all those mundane tasks, we really have to look beyond our own facade of intelligence. Think about a GPS. It is absolutely brilliant at what it does. It gives you perfect directions. But ultimately, providing data is just lip service. An AI is an excellent task follower, but it has absolutely zero sentience. It cannot act to make you happy because fundamentally, a piece of software does not care about you. It literally has no capacity to care.
For years, we kind of hid behind this mask of intelligence, right? We thought our ability to calculate and reason was what made us special and superior. But AI is proving us wrong on that front. Our true, irreplaceable superpower is actually empathy. If your mother is sad, you become sad. Machines do not feel that. We tell stories, we work together in groups, we naturally rush to help each other out in distress, and we actively try to make others happy. That shared, lived experience, that is exclusively human.
So here is the final thought I want to leave you with today, and it's a challenge directly to you. We started by asking what happens in a utopian world where every mundane task is handled by AI. The answer isn't that we become obsolete. No way. The answer is that we are finally freed from that facade of intelligence. So, in this rapidly approaching new world, how will you choose to care? How will you choose to love? And how will you build community? Let that guide you as you navigate the AI revolution. Thanks so much for joining me on The Explainer today, and keep learning.